G'day coppers, welcome back to the bush. Actually the front yard again today. Now I've flattened the battery on the 80 series and I thought, well, let's try and jump start it with a Makita tool battery off my torch and a couple of forks out of the camping kit. Make it a bit of a challenge. Let's get into it. So as you can see, I'm not even getting lights on the dash. Not even a click out of the starter motor. That's no good. Let's chuck the multimeter on the battery and see where we're at. So I've set my multimeter to DC volts, negative and positive. As we see, we're sitting on about 6.5 volts, and that's about halfway up of what it should be. That's why it's not starting. That'll teach me for leaving the headlights on. Anyway, let's have a look at how we're going to hook up the tool battery. So here we have our tool battery. We've got our negative side and our positive side, as you can see here. Now that correlates with the negative and positive terminals. So we need to connect the negative side to our negative post and our positive side to our positive post. And we need to make sure that we get the polarity 100% correct. Now you could use wire. I don't have any wire in the 80 series. I probably should carry some spare wire, but I don't. But I have forks and a hammer. So let's have a look at that. That was a lot of messing around to get these into the right orientation. It would have been considerably easier using a couple of wires, but I set the challenge to do it with what I had in the car, and this is what I had, so this is what I'm using. Righto, let's show you how to connect it up. So now we've got a pretty much fully charged 18 volt Makita 6 amp hour tool battery. Nothing special, not too bad. So we get our custom forks, and you need to find something that's actually going to jam into the terminals there. And we can put that on our terminal. Make sure, of course, that our negative is on our negative side. And our positive, of course, will go onto our positive side. That's one side done. You have to watch the sparking on the other side. There we go. I'll cinch these down just a little bit because I can. And before we actually try it, let's show you what we're actually doing here on a diagram. So let's have a look how we're going to connect it up. So we've got our car battery here and our tool battery. We've got the negative on the car battery and the positive on the car battery. We've got the negative on the tool battery and the positive on the tool battery. Nice and simple. So all we do is we join the negative on the tool battery to the negative on the car battery, and then the positive on the tool battery to the positive on the car battery. Nice and simple. That's parallel. So this is a schematic diagram of our two batteries in parallel with our motor load, or any load for that matter. So we've got 10 volts on our depleted car battery, and we've got 18 volts on our tool battery. Now to work out your voltages, you usually use what's called Kirchhoff's voltage law. Now all it means is the sum of all the voltages around the loop equals 0. But 18 volts can't equal 10 volts. So we can't use Kirchhoff's voltage law to work anything out. Luckily though, batteries aren't ideal power supplies. They have an internal resistance. So we can use something else, and that's Kirchhoff's current law. At least we can work out the current. Let's check that out now. So here we have a more accurate representation of what we're actually dealing with. So we've still got our load here, we've got our 10 volts here, and we've got our 18 volts here. But we've put resistors in series to represent the internal resistance of the battery and battery pack. Now, Optima quote an internal resistance for that battery of 0.003 ohms. So it's not a dead short, but it's not a lot of resistance there, is it? And now our battery pack. Now our battery pack is actually made up of multiple 18650 batteries. Little batteries, not too much bigger than the likes of a AA battery. Now they're 5 in series to add up to our 18 volts, and 2 packs of 5 in parallel. Now that gives us an overall internal resistance of 0.025 ohms. So let's have a look at Kirchhoff's current law. Now we can read that there. All the currents entering and leaving a junction must be equal to 0. Don't worry too much about that. That is the formula that we're looking at. So if we plug all the figures in, it gives us a massive current of 286 amps heading out of our battery pack and heading in to our car battery. Now obviously that little battery pack, well, that's not going to be able to support that sort of current. In fact, the cells are rated at 20 amps max. So because we have two lots in parallel, that gives us 40 amps max heading from our battery pack heading into our battery. That's nothing to be sneezed at. That's a fair bit of current, and that's the reason my forks were getting pretty warm. So don't go using thin wire when you're connecting your tool battery to your battery pack, because you'll only let the smoke out of the battery. Okay, let's see if we put enough juice from that battery pack into the car battery to start the cruiser. So now we know how it should work. Let's check if it does work. Now I've had this connected up for about a minute or so. Now these are starting to get warm, which tells me the energy from the battery is heading into our bigger battery. And ideally we connect the negative side to part of the engine, but obviously that's not an option because we're using forks. Anyway, let's go give it a kick of the guts and see if she'll start up. Hey! Alright, now we've started up, we can disconnect this, our battery, put that off to the side, and we need to let our alternator keep charging our battery. And I'd run the engine for a good 10 to 15 minutes at idle, maybe give it a bit of a rev once she warms up a little bit, but we want to get some decent amount of charge into this battery. Now if you're wondering how much charge we used from this battery, there you go, we started at 4 bars and now we're back down to 3 bars. So yes, it did use a little bit of its capacity, but I'll be throwing this one straight back onto the torch where it came from. So what do we think in the end? Well, it's definitely not as easy as asking your mate to pop his bonnet, connect up the jumper leads and off you go. But it's definitely doable. Now you might have to watch out for modern vehicles like common rail diesels and petrol injection cars. They mightn't appreciate the 18 to 20 volt into the ECU. But other than that, got an old school 4-wheel drive like this one, basically no electrics, you're good to go. Anyway guys, now if you like this video, don't forget to give it a thumbs up, and if you didn't, by all means, give it a thumbs down. Not once, not thrice, but twice. Thanks guys, see you in the next one. So if you've enjoyed this content, don't forget to subscribe to the channel and ring that bell icon. It's really important to us and you won't miss out on our future content. Now if you want to support the channel, by all means, consider becoming a patron on Patreon, and you get things like early access to our videos on YouTube. Either way, we hope to see you out on the tracks.